This video will give examples on how to do proofs and induction. Prove that the following are false. All prime numbers are odd. To do this, all we have to do is come up with a counterexample, or an example of one prime number that is not odd. So we can say false because 2, which is a prime number, is not odd. Alright, we want to prove that the graph of every function has a y-intercept is false. So all we have to do is come up with one graph that does not have a y-intercept. So for example, the graph of y equals 1 over x looks like this, and it never touches the y-axis. And then the square root of x squared equals x. That's false, because if we plug in a negative number, such as -2, then the square root of -2 squared equals 2, and not -2. Prove that 3 to the power of n minus 1 is divisible by 2 for any integer n greater than or equal to 1. We can do this by induction, so we'll start by proving the base case where n equals 1. In that case, we have 3 to the power of 1 minus 1, which equals 2, and we see that that is divisible by 2. Now, we assume that 3 to the n minus 1 is divisible by 2. And we need to prove that 3 to the n plus 1 minus 1 is divisible by 2. So our first statement here just means that 3 to the n minus 1 equals 2k for some integer k. Now, if we multiply everything by 3, what we end up with is 3 to the power of n plus 1 minus 3 equals 6k. Now we can do a bit of rearranging. 3 to the n plus 1 minus 1 equals 6k plus 2. Now we can factor out a 2, and we have 3k plus 1. Now, we know that 3k plus 1 is an integer, so that means that 3 to the power of n plus 1 minus 1 is an integer multiple of 2. So we are finished with our proof. Prove that the sum of the first n odd numbers is n squared. So again, we'll start with a base case, n equals 1. So this means proving that the sum of the first one odd number is 1 squared. Obviously, the first odd number is 1, and that is equal to 1 squared. Now, we're going to assume that the sum of the first n odd numbers is n squared, and we need to use that to prove that the sum of the first n plus 1 odd numbers is n plus 1 squared. So one way to represent the nth odd number is 2n minus 1. So essentially, what we're doing is adding up 1 plus 3 plus 5 all the way down until 2n minus 1. And we're going to say that that is equal to n squared. Now what if we take the first n plus 1 odd numbers? Then what we're doing is we're adding 1 plus 3 plus 5 all the way down until we're still going to have 2n minus 1, and then we'll have a 2n plus 1. So that would equal n squared plus 2n plus 1. But now if we factor that, then that's just equal to n plus 1 squared, which is what we were trying to prove in the first place.